Welcome everybody, I'm Jerry Eschba, and today we're going to talk about running cloud technology on-premise. And this is something that is not really easy to do, but tools like OpenShift are making it a lot easier for us. And just a little question here. When we were kids, we asked why a lot. If you ever have a kid, they're always asking why. And it's inherent in our nature to ask the question why. And there's websites and blogs dedicated to how to get your kids to stop asking why. And if you look at on-premise cloud, there's a lot of things and a lot of questions and a lot of unknown things that have to be solved. And kind of back to why, if you want to uncover the root cause of a problem, just ask why 5 times. It's in our nature, and it really drills you down. It also uncovers any misconceptions or truths. So to get started, I'm going to talk a little bit about why we're here, why this is important, why anybody would want to run cloud technology in a traditional data center, and why this is so hard. So first, a little bit about, oh, my clicker's not working, okay. My computer locked up. There we go. Your perspective. So I've been talking to people around the conference. I've kind of been a little surprised as to how many people are still very grounded in traditional data centers and RHEL, and not even running virtualization, but running on physical servers. And but a lot of people have moved to virtualization, and this is really the next step, is to move to containerization. And why you'd want to run on a traditional data center? Well, one, sometimes cloud native is just not an option. Other people are concerned with avoiding the cost and vendor lock-in that you get with a cloud provider, to support legacy applications that aren't cloud ready, and to collaborate and to containerize mission-critical applications and databases. People are wondering, can that be done? And what problems might I run into containerizing databases? And I'm going to share some stories with you on that. But the reality, we've heard this throughout this conference, is that hybrid hosting is here for most large organizations. You're not just going to jump to the cloud like a startup might. Although cloud technology is awesome, I'm very excited about what AWS and Google has done. I've been using AWS for a while now. But this presentation is really focusing on how do you run those container workloads in an on-premise data center. So a little bit about me. I'm old enough to remember seeing a man walk on the moon for the first time, and that really inspired me as a kid that anything is possible. I went to engineering school, and kind of interesting engineering school, the first lecture I ever heard by the Dean of Engineering talked about engineers being problem solvers. And I went out through engineering school, never learned how to solve a problem. And on my commencement address, quite ironically, they talked about engineers being problem solvers. So it's like, okay, I got the bookends, I just don't have the middle. And fortunately, I worked as a TV repairman for a while through college, so I did learn some good troubleshooting skills. But that's what most of us struggle with. And I was really frustrated at the slow pace for innovation to deliver value as a young engineer. And kind of broke that down. Originally, I worked in robotics and automation and really eliminating cumbersome processes. And we can do that now with tools like Ansible and YAML files to be able to configure an entire layout or template for deploying our OpenShift configurations. Then started stumbling across quality issues. In the early days of software development, you wrote code, you tested it, you shipped it, you tested it some more, your customers tested it, and then your president or your CEO would give a big demo in front of a bunch of people and it would crash. And really frustrated me on the quality and really drove me to testing. And that kind of led to the visibility and the lack of visibility, which drove me to monitoring and having visibility on systems. We all kind of, if you just think about something you don't know anything about, so if you know nothing about Google Cloud, for instance, getting visibility into that, getting those hooks into there to be able to see what's going on is a great way to understand and build confidence. But until we know where to look and when to look, you're really lacking without good monitoring. And then this next one's going to take a little bit of explaining. Has anybody here heard of an author called Joshua Cooper Ramo? Nobody? Okay. Great book called The Age of the Unthinkable. And this gentleman has a very interesting perspective because he's an American who lived and grew up in China. So he's got a very international perspective. And he talks about the barriers that bind technology. And on one side, you have the barrier of no return. So if I had to take your laptop or your cell phone away, or your teenage daughter's cell phone away, all hell's going to break loose. Whereas the other barrier is the barrier of empire. And empire isn't necessarily a bad thing, but it's what we are. Red Hat's an empire, our government's an empire. We can have our own little empires that we create in our organization. And that's a barrier because an empire is making money and living off the way things are. So that's really a barrier that binds moving technology forward. So you got the barrier of no return and the barrier of empire. And I see OpenShift is really breaking that down because one of the things you get with cloud technology is agility and flexibility. One thing you have with a traditional data center is rigidity and reliability. And OpenShift bridges that gap. Kind of my experience, I'm currently leading a DevOps team at the United States Department of Agriculture, DHS, and FEMA. It's a long story. I'm a serial entrepreneur. I've founded a number of software companies, and I also serve as a strategic advisor for corporations looking at M&A and other things where they need advice on technology stack and market trends. So why is this important? We're in the middle of the biggest IT disruption since virtualization. We don't just have DevOps. We've got the ubiquity of Agile. We've got cloud, test-driven development, security, operations, continuous everything. Bring your own device, big data, artificial intelligence, and heightened user expectations. It used to be if a website loaded in 10 seconds, we were excited. Now if it's taken 100 milliseconds, we've got a problem. And I'm exaggerating a little bit there. And I see Docker as the tool that really bridges a lot of these technologies and brings it together in a more agile, flexible environment. And this is Clayton Christensen, I believe's mudslide theory about disruptive technologies. And we're in a state where we really are experiencing a lot of disruption. And that disruption usually starts with low quality of use. These are the low-hanging fruits, the things we don't mind making mistakes with. But what's really great we're seeing with Docker technology, Kubernetes, and OpenShift is we're breaking through to the most demanding uses. We're hearing use cases here of large organizations deploying Kube at scale, OpenShift at scale, and being able to do this for mission-critical applications. So why cloud in a traditional data center? You can deploy modern service-based architectures on-premise, microservice, macroservice, integration with legacy applications. There's also edge cases where security truly is an issue, and I'd like to talk a little bit about this because a lot of times people say the cloud is not secure, and really that's, I've been on, how can I say this carefully, I've been advising companies that have been using that as a way to slow market adoption down in the past by saying the cloud is not secure. The truth is anything can be insecure, anything can be secure. Just because it's on-prem doesn't make it more secure, but there is that perception that on-prem is secure. And there are edge cases where you absolutely must be on-prem, especially in the DoD space or things where really proprietary information is being stored, and there's reasons to do that. A predictable cost model. I know somebody that started off with AWS, and their first month bill was a couple $100. Then this business started taking off, and they started seeing zeros getting added onto their bill. And they didn't have any way to really control that. So that's one reason people look at a traditional data center. Avoiding vendor lock-in. Right now, there's some great cloud hosting providers out there. It might not be the same landscape 3 to 5 years ago. When we're building enterprise applications, we have to think not just today, but 10, 15 years in the future, because you never underestimate the permanence of a temporary solution or a short-term solution. And if we have good, agile software practices, good distributed architectures, we can replace pieces of our application, but the hope is that the framework will live for a long time. This next thing about ownership, back before I even ever heard the word cloud, I was doing a project for some community colleges, and we were actually doing a cloud-based learning solution, as I can talk about it now using the word cloud that I didn't know then. Basically what it was is we had distance learners who could actually submit code that ran a robot, see the robot run, we'd create a video, and we'd return that video to them, and they could watch it on their laptops because they didn't have the power on their laptops at the time to run the solution. Well, there was this huge battle going on about what community college was going to get the servers to run this technology. And personally, I'm a software guy. I don't care who gets the technology. But it turns out in the end, actually having those servers on premise gave them a lot of clout. We're able to get additional funding. And a lot of things were driven by owning those servers. And unfortunately, that's still the culture in a lot of places. Also, a lot of traditional data centers can really help you short-circuit the whole certification approval process you need to actually get an application out to your customers. So kind of in conclusion here, AWS, Google, Azure, they're all great if you have no legacy technology or legacy culture. And we're going to talk a lot about culture. It was great to see the keynote just a little bit ago talking about feelings and culture, because those are really the barriers I see. The technology can be the easy part. I know it's tough, but when you start dealing with people, dealing with organizations, those are some of the challenges we really have to deal with. So why is this so hard? We got the lack of visibility, getting visibility into not just systems, but getting visibility into processes, getting visibility into why things were done this way when those people are no longer with the organization. Fear of the unknown, change and disruption. There's comfort in having things and knowing how things are done currently. I went through a time management class. I think it was Franklin Planner that put it on a while ago. And they talked about learning new things. And you go from awareness, interest, comfort, and habit. And in between interest and comfort, there's this phase called awkwardness. And we all go through it whenever we learn anything new. And it's where most people give up, is they get into this awkward phase. And any change to any organization is not going to be easy. We've always done it this way. And then this next one, Blamosaurus. Does anybody know what that is? Blamosaurus? Okay. I used to be with a company that got acquired by SolarWinds, and we had this little monster called the Blamosaurus. And it's basically, pointing fingers at operations or DBAs. And the point is, if you're always looking to blame somebody else, nothing is going to get done. And that creates silos. And really important is the culture and how you work together with different people. And the reality is things are never how they initially appear. And that's what I'm going to talk about a little bit later as I get into a case study here. So the culture clash. If you look at traditional on-prem versus DevOps cloud, and this is kind of an old school versus new school thing. I don't say young versus old necessarily, because there's a lot of old people working in new school and a lot of young kids working in the old school arena with that mindset. But traditional on-prem is really, the process is adapted from factory work. Henry Ford did a great job of automating factory production, and a lot of IT shops have applied that. So you've got an assembly line practitioner. If you look at DevOps and cloud, you've got a more multifaceted engineer. The repetitive tasks should be automated. So you don't need to have a lot of people doing the same thing. You need people that can think and act. In a traditional on-prem system, a lot of times your main gauge is hours worked or tickets closed. Whereas in DevOps and cloud, it's all about the customer. It's how much value can you deliver to your customer. On the one side, you've got manual processes. On the other side, you've got automation. You also have secure on both ends. And probably the way you get to security is very different between these two pillars. On the traditional side, you have rigidity for security. So preventing things to change is the way you obtain security. In more cloud environment, it's how fast you can react, how you can be agile, how you can respond to change, how you can respond to those latest threats quickly before they impact your organization. And actions are rewarded, are driven by reward and bound by fear. And that's kind of the takeaway quote on this. So, the case for automation. Whenever we hear about somebody automating a job that we do, especially something we like to do, it's a little scary. And a lot of people look at it like, oh, we're going to replace all these people, we're going to downsize, we're going to lay off people. I was talking with a group at a large software organization that's not Unix-based, if that tells you anything. And their database administrators were terrified of this thing called DevOps, because DevOps is going to take their jobs away. And the way you need to look at this is it's more possibilities. Could you imagine life today without technology like, let's just say Bash, or say Ansible, or any, we've got all these tools, and without them, we can't do our jobs. And the healthy way to look at automation, in my perspective, is to look at it as more possibilities. We can do more work faster. If you don't have enough tasks to do, please find me or find an open source project, because there's plenty out there that needs to be done. There's no shortage of work. Continuous testing, integration, monitoring, delivery, improvement. And I really, is anybody here familiar with Net Promoter Score? Okay, can you tell us what it is, sir? The Net Promoter Score? Do you know the Net Promoter? Yeah.
So what is the score of how the whole process is working? The more automated and refined it is, the higher score you get.
And what's the one question? So the Net Promoter Score is based on a single question.
You
Thank you. Yeah. So it's really just one question that comes down to rating a company. If you look at like Apple, they've got a very high Net Promoter Score. So if you're likely to recommend their products or services to other people, that drives up the score. They also have this thing called detractors, I think it is, where if you have a bad score, it costs a lot more than a good score. So you don't want many people that won't recommend your product. And if you really look at DevOps, if there's one metric we can put on DevOps, I see that as the frequency deployment. How quick you can take code from the developer, get it into your customer's hands, and have them see value in that. And I've kind of simplified the little DevOps life cycle, if you will. And I think everything, there's a lot of these that have like 20 different steps, but really to simplify it, I think everything falls into one of these 5 categories. You're defining, you're coding, you're testing, you're deploying, you're monitoring, and then you're taking that feedback and putting it back into your definition for your next iteration. And the faster you can get that circle to spin, the more effective your organization is going to be. So do a little case study here. And this is actually, if you Google search Phoenix RFI, Request for Information, you're going to stumble across the same requirements that I did for this project. They want an agile process, cloud technology. It's a modernization effort. And oh, by the way, you have to run it on-prem in a government-owned and operated facility. And we were kind of struggling with this originally. Fortunately, we'd been using containerization in the group I'm in for quite a while. Very familiar with that technology, and was using some other orchestration frameworks in the past, not to mention any names, but really was intrigued with Kubernetes, and then discovered OpenShift, and the fact that it's based on Kubernetes and has already gone through that learning curve. There's a lot of other tools out there that are still migrating to Kube. It's pretty much a de facto standard that Docker and Kubernetes are ubiquitous in the market, so you need to embrace those if you're going to move forward. So this was my challenge. And my team's challenge. And so our on-premise hosting environment was designed to be rigid. It's a VMware server farm running RHEL 7.x, NetApp storage on the back end, I believe, both physical and logical networks. But you talk to the people there, and they're very grounded in their infrastructure and their air conditioning units and the structure in the systems that they have at this on-premise. I've worked with other clients as well, and it's very similar. It's always a little different, but it's very similar as to people that are really grounded in on-premise hosting. And actually, one of our customers a while back was with a major insurance corporation, and the only connection the database administrator had to the storage administrator was an email. And he said, if I put urgent with a bunch of exclamation points, I sometimes get a response in a couple hours. If I just say, what I need, I might hear it back in a week. And that's like totally siloed organization. And that's what we're breaking down with the DevOps movement. It's exciting to hear about what's happening here at Summit. So our cluster is agile. So we've got this rigid environment, but we're able to deliver cloud services through this agile cluster. So we've got OpenShift. We're still running 3.5, although we're working on getting up to 3.9. Ansible server for configuring the server. But what we've actually seen is our use of technologies like Salt and Ansible is going down. Once we get OpenShift installed, all our configuration is done within the OpenShift platform. So our need to actually use configuration management on the server is not as much as it was in the early days of Docker. The projects we've set up inside OpenShift, we've got a CI/CD project, an alpha project, a smoke project, a test project, UAT, stage, validation, production, and anything else that needs to be spun up quickly. So as you see, we've got about 7 times pre-prod that we do in prod. And this lets our developers test very easily. It also supports our continuous delivery pipeline. As far as the pods we're running, we actually looked at microservices originally. Because of the nature of this application, a traditional database seemed like a better solution and more traditional data model, because with microservices, you want your data to live with your service. And this just didn't seem like the right fit, so we've actually went with what I call a macro service. So we've got a number of Tomcat containers running different pieces of the application, but it's backed by an Enterprise DB Postgres database cluster, and it's 100% containerized. We're also looking at, we're also using NoSQL solution, MongoDB, as well for document stores and things that don't really fit into the relational database model. Kind of gives us the best of both worlds. Since this project is a modernization effort, we've got some legacy to deal with. So we're actually using Pentaho to do some of the data migration, and then Nginx just as a proxy on the front end. So our CI/CD pipeline, it's actually, we're using Confluence, Jira, and Bitbucket on the top end. A lot of people leave those tools out. Very, very important. If you don't have a place to track what you're going to do, figure out what the next best thing to work on, and really share information, it's really important to have these systems in place. Also using Jenkins, CloudBee flavor of Jenkins. And we've got Fortify and JUnit and Cucumber. I'm just going to check my time here. And we're also using Maven. So we've got Maven for builds, Nexus for our document store, Web Inspect, and App Detective. And really the key here with the CI/CD pipeline is to be able to very quickly take a change from our development, merge it through the pipeline. If you noticed earlier, we had the smoke test and then a test environment. The smoke is run every time a new change is committed. And we see a lot of errors in smoke because there's something that doesn't compile or doesn't work the way we expected, or the integration test failed, or some of the monitoring and code scanning isn't up to standards. So when we see that, we actually flag that, and that goes back upstream. Cucumber for user experience testing, and some other technology to actually monitor Web Inspect and App Detective on the outlines. So some outliers here. We tried to containerize 100%. And we're using Splunk to monitor the containerized environment, but we weren't able to easily containerize Splunk. And I was actually just talking to them here, and it sounds like it's still a little on the bleeding edge. They're talking about having something soon, but this actual Splunk install is still running on virtual machines. MongoDB's Ops Manager, and I was a little confused here in that I originally was not worried about Mongo and containerizing it. I was very concerned about Postgres, and granted, Postgres was a little more mission critical for our application. And it actually turned out that there's a little more issues around containerizing Mongo than there was around Ops Manager, and we're working with Mongo to improve that and get that out. Also, there's some Windows dependencies, and I was really excited about KubeVirt. And being able to run Windows workloads inside of Kubernetes, because that's going to give us a great advantage going forward. But we weren't able to actually have a good solution right now, aside from other VMs, for things like Selenium testing and being able to spin up and test the application in Internet Explorer or Edge browsers. Tableau actually was on the alpha program for Tableau to be able to, for the Unix version of Tableau, because that was still a Windows solution. And we're still running the Windows version of Tableau. And I'm not sure how easily a system like that is going to be to containerize, but we will find out. So here's some lessons learned. First, what we did right. We hit our delivery targets. The tool selection, very happy with our entire stack. Tools are doing what we expected them to. The vendors that we've selected are very responsive and working and helping and support us. We're using Scrum methodologies for development, and that's going very well. We've also had an A-player mentality. I have no idea why I'm on this team, but for hiring and retaining people. So we're actually some of the smartest. I've been on 3 incredible teams in my life, and this is one of them. So it's a really great team to be a part of. We've engaged DevOps from the beginning, and I was originally the only DevOps practitioner. I set up OpenShift myself, and there was some push to, oh, you got some other projects you can work on till the coders are done coding, and then you can go deploy, and we won't be ready for you for a week. And I pushed back really hard. I'm like, no, we need to get up front. We need to be part of the process from the beginning. And that was really critical because it helped us select the right tools, and it started that working relationship between DevOps, traditional ops, data center, and our development team to be able to pull that all together. And finally, communication. If you really look at this, the technology's there, but being able to communicate with people, communicate with customers, partners. In the federal government, we're bringing a lot of different organizations together. I've been on technical calls with 3 or 4 different departments trying to solve problems and figure out the best path forward, and having good communication. And I always talk about communication. The best thing you can do is be face-to-face. This is the best form of communication you're going to have. Second best is something like WebEx or NetMeeting, desktop sharing. And then third is the phone. And everything else falls below that. And unfortunately, a lot of people will send emails and wondering why things aren't working, problems are escalating. And we have a great communication on this team. And I talk about what we did right because, failure is obvious, but success is often very elusive. So some lessons learned. We hit our delivery targets. Didn't you just say that? Yeah, but with hours to spare. So we were really relying on heroics. And it's never a good process when you're just relying on, late nights, long hours just to pull something off. That's not repeatable, and it's not sustainable. We tried using Scrum for the DevOps team, but when we have external dependencies and interrupt-driven teams that are responding to issues and responding to questions, it was very hard to use Scrum methodology. So we've gone to more of a Kanban methodology, and it's working a lot better. I underestimated the size of the DevOps team. I was originally thinking I could do this single-handedly, maybe with one other person, and we needed to bring on a lot more resources to be able to do what we needed to do on time. And there's a lot more work that's still expected and still going on with this problem. And also had challenges containerizing and running databases in containers. It's doable. I highly recommend it. I would recommend having good monitoring, good visibility into containerizing. But we are containerized Mongo and Postgres. They are working. But that is a little more of the challenging side of actually working with containerization, is actually getting your database and your persistence model correct. We cut some important components to meet deliverables. We've since added those back in, but to hit our target, we didn't have the full monitoring suite built out using Splunk. We didn't have live, didn't do as much load testing as we would have liked. And I talked about coordination between multiple teams. And really, we like to make a lot of mistakes. I mean, that's how we learn, that's how we grow. I never like to make the same mistake twice. So this is really something that we focus on here. And then finally, and I kind of left this out, I've moved many companies off Gantt-based project planning, waterfall. I'm a big proponent of Agile. Was doing Agile before I even knew the name because people kept telling me to do Microsoft projects. We used to use CA Super Project back in the day, and it was never right. We always had these Gantt charts. Well, I found a good way to use a Gantt chart finally, and it's to create urgency for your partners and people that you need things from. And by putting that buffer in the project, you can set timelines and deliverables for partners. So, hey, if this slips, here's what it's going to do to our customer delivery. And you need to be able to articulate that in a very good sense. And a Gantt chart is a great way to be able to do that. So finally, just kind of conclude here is we have the technology. We've got Docker, we've got Kubernetes, we've got OpenShift. And really, given time, money, and great leadership, anything is possible.